Today we're going to be talking about measuring segments. And during this lesson we're going to be concentrating on two specific postulates. Alright, and just as a reminder, postulate or an axiom is a rule that is accepted without proof. Okay? It's a rule that is accepted without proof. So, our first postulate is the ruler postulate. And the ruler postulate states the points on a line can be matched one-to-one with real numbers. The real number that corresponds to a point is the coordinate of that point. The distance between points A and B, written as AB, is the absolute value of the difference of the coordinates of A and B. So for example, if I were to look at this line right here, so I have points A and points B, and they correspond with a specific coordinate. So let's just say this is negative 5, and this is negative 3. Okay? So the um, the coordinates of those points stated by the ruler postulate correspond with negative 5 and negative 3. So A with negative 5, B with negative 3. And in order to find the distance between the points, we can plug it into an absolute value problem. So we can say negative 3 minus negative 5, absolute value of that. So we could leave, change, opposite. So in this case, the absolute value of negative 3 plus 5 would be 2. Okay? And the absolute value of 2 is 2. Okay? So that is the distance between AB in this particular example. All right, our next postulate we're going to be talking about is called the segment addition postulate, and it literally states what the name says. So in this case, the segment addition postulate is saying if B is between A and C, as you can see here, then AB plus BC is going to equal all of AC. And if AB plus BC equals AC, then B is between A and C. All right? It's just stating the obvious. So for example, if I say that AB is 4 and BC is 2, okay? The segment addition postulate is saying that I can do 4 plus 2 to get the length of AC, which would then be 6. It also states that if I was given the length of AB and the entire length of AC, I could find BC by subtracting 6 by 4 to get 2. Okay? Alright. So, our first example we have, it says, find the distance from, I think it's Lubbock to St. Louis. Okay? Or St. Louis. So, we have a map here, and it's showing us the distance between Lubbock to Tulsa and from Tulsa to St. Louis. Tulsa in this case is between Lubbock and St. Louis, so we could take 380, all right, which is the distance between Lubbock to Tulsa, and add it to the distance between Tulsa to St. Louis, which is 360, and I could find the entire distance. Alright, so add these up, and the entire distance for this would be 740 miles. Okay? Alright, let's do another example. Alright, we are trying to find the segment, the length of GH. Okay, we don't know what it is. So we know what FH is, and we know what FG is. So we could take 36 minus 21. Okay, we're taking the length of the whole, subtracting part of it, and we will get 15. Okay, so in this case, GH is 15. Okay, all right. Um, we also, in this particular section, have a vocabulary word that will help you in doing some of the problems that you will come across when talking about these two postulates. In this case, it's called it's congruent segments. And congruent segments are line segments that have the same length, because we know congruent means same. Okay, so for example, we have AB is equal to CD. Okay, which means that segment AB is congruent to CD. And the way we can tell that they are congruent is not because they just look congruent, but because there's this tick mark that is telling you these two are congruent. Alright? If two segments have the same number of tick marks, that means that they are congruent segments. Okay? Alright, so we are going to quickly do an example. Get that a brighter color. Alright, so here I have a segment, okay, and I am going to state that this is M, and this is O, okay, and this point in the middle is R. Alright, now, in order for me to know that these, and I'm going to state that MR is congruent to RO. It's congruent to RO. So we could write it like this. MR is congruent, and the congruent sign is that equal sign with a little squiggly on top, to RO. In this case, they are both segments, so we can't forget that. Okay. All right, and because these two segments are congruent to each other, so there's another vocabulary word that I did not include on here, and I will include it now. And this states that, and this vocabulary word is a midpoint. And a midpoint is divides a segment into two equal parts. All right. So in our example here that we have, R is our midpoint. Okay. So R is our midpoint. And we can actually use all of this information, knowing that these two are congruent to each other and knowing that R is the midpoint, to solve a problem. So for example, I could ask you to find the length of RO. And I could say this is 2x plus 8. And I could say that this side is 3x minus 12. And I can then set these two equations equal to each other. I could say 2x plus 8 equals 3x plus 12. And if you can, or minus 12, excuse me. And if you can think about it this way, we want to set these equally to each other because the two segments are equal to each other. So in this case, we could solve for x, and then whatever we find x to be, we could plug it back into the original lengths, which could be 2x plus 8 or 3x minus 12. All right, so why don't you solve and find the length of MR for me, of MR. All right, do that in your notes, and I will check for it tomorrow. And that brings us to the closing of everything you need to know about measuring segments. So we have the two postulates, congruent segments, and a midpoint. All right.